In previous videos, we talked about probability in the context of sets, um, sample space, where these outcomes and events are subsets of the sample space. And outcomes and events could have been things like, if you toss a coin, is it a head or a tail? If you flip a die, is it how many spots are facing up? 1, 2, 3, 4, 5. If you pull a card out of a deck of cards, what card is it? Is the event that it's a red card? Or if you're dealt a hand, is it a flush or something like that? All these kind of weird, I call them weird, outcomes and events. Not quite numbers. Now let's jump ahead to this idea of random variables. In some ways, it's so subtle, you wonder why it's a big deal. Because what a random variable is basically a mapping from an event in your sample space to the real numbers. So that we can then talk sort of strictly math. The event is a number or a combination of numbers. So some of these mappings will be direct. Like you could say the tail in a coin toss maps to a 0 and the head maps to a 1. So you map those sort of physical events to real numbers, 0 and 1. Or with how many, if you toss a die, just map it to the numbers, 1, 2, 3, 4, 5, and 6. It almost seems too easy. So you wonder what the big deal is. But we've converted things into real numbers. And here's an example where the mapping isn't quite just one-to-one type thing. Let's say you do 2 coin tosses in sequence, and you're interested in the number of heads, those total heads in those 2 tosses. So the possibilities are your first toss is a head, second toss is a head, first is a head, second is a tail then a head, or you roll 2 tails. Here's how many heads you get for those cases. The original sample space was these things in terms of heads and tails. The new sample space, after mapping using random variable mapping, are 0, 1, and 2. Nice real numbers. And the probabilities carry over. So now we say the probability of this x is the random variable now. Probability with the small p of that x. The arguments of that probability thing, possible arguments are 0, 1, and 2. So here's the notation for a discrete probability of the random variable x. And we're not going to do things like in my course, my probability review. We're not going to discuss combinations and permutations and stuff like that. Kind of skip some of the hard stuff. We go right to where we're dealing with numbers, and usually somebody gave us these probabilities. And then we're going to generate other probabilities from them. But we're not going to do things like calculate, what's the chance of getting a flush if you're dealt 5 cards from a normal deck of 52 cards, stuff like that. So that's the concept of a random variable. So we went from intuitive concept of probability to sets with outcomes and events, sets and subsets, to random variables, where now we're dealing all with real numbers. And our probabilities will map from real numbers to other real numbers. If you had 3 coin tosses, it's a similar type of thing. Your original sample space would be these 8 occurrences, these 8 outcomes. The number of heads, you could calculate those probabilities. These would be the number of heads, and these would be the probabilities of getting those numbers. But the new sample space would be the real numbers 0, 1, 2, or 3, and 3. The probability axioms are satisfied. Each probability is, in this case, strictly greater than 0, but you need it to be greater than or equal to 0. If you sum them all up, since they're, in this case, don't overlap, they're disjoint, they sum to 1. So those are checks on, are the probability axioms satisfied? Then we just do things from there. And